Hey guys, welcome to Tech Fortitude, and this is the most requested video on our channel. And today in this video we're gonna cover Python tutorial for beginners. So this video is completely for beginners who don't even know about programming. You can watch this and learn about Python, and we're gonna cover a lot of topics starting from basics to all the logics and loops, object-oriented programming, everything. But of course I'm not going to cover all the popular frameworks or modules. I'll be making separate video for them, but this course will be covering all the basic concepts in Python, and this is a full 3-hour course, and hope you like it. If you find this course very helpful, please leave your comments in the comment box down below. And I have divided this course into 11 parts, and these 11 modules will be separated inside the video itself. You can check out the video chapters to jump to any particular chapter which you require. And also in the end of every module I'll be giving you an activity or a project which you can submit it by creating the project and posting it in your GitHub repository, and then sharing that link to the link in the description box down below. And now without any further ado, let's get started. So now we're gonna see the introduction of Python and some of the history and all the information which is required before starting with Python, and then slowly we'll proceed with the basics to advanced logics in Python. And yeah, so without any further ado, let's get started. This video is sponsored by Assista AI. Are you tired of juggling repetitive tasks across multiple apps? Let me introduce you to Assista AI, the game-changing multi-agent platform that is about to save you hours every day. Assista AI connects to over 100 apps like Gmail, Slack, HubSpot, and Notion, automating complex workflows with simple voice or text commands. No coding needed, just say something like, create a LinkedIn post about the dominance of artificial intelligence in today's world. And Assista's specialized AI agents get to work handling everything from start to finish. This platform is a productivity powerhouse. Whether you're managing meetings, organizing files, or streamlining sales, Assista makes it effortless so you can focus on what matters the most. Ready to transform your workday? Sign up for Assista AI today using the link in the description box down below. It is super easy to get started, and trust me, you'll wonder how you ever worked without it. Click the link in the description box and try it now. So let me demonstrate how you can share your projects on your GitHub repository and share it in the link. First, create a new GitHub account or log in with your existing account, and then I want you guys to create a new repository. Name the repository as Frissco Academy. Make sure the repository is in public, and then just create the repository. Now you have an empty repository. Click on this uploading an existing file. So let's say you have a file here. Go ahead and choose your file by clicking here. And then just upload it. Comment changes. And there we go. Now what we need to do is go ahead and copy this URL and then navigate to this site. The link will be in the description. In this site, go ahead and click on Start Form, and then enter your name, and then your education, and then the course. So this is Python full course for absolute beginners. So select that, paste your repository link which you copied, and submit. That's it. So now this is how you submit your GitHub repository with all the projects loaded in it. And then you can upload any type of file by just going into add file, upload files, and then upload all the projects with their name and the module number which the project was given, and then share the link once. Welcome to the first module of this course, and in this module we're going to see all the basic things about Python, and we're not going to cover any programming part in this module. We're just going to see about the information about Python and how to download and install Python, and that's it. So this part is for beginners, and if you are an intermediate programmer or if you know all these stuff, you can go and skip to the next part. And let me give you a quick overview of Python programming language. So Python is a versatile high-level programming language. So there are different type of programming languages like low-level programming language, high-level programming language, and machine code. So some of the example of low-level programming languages are assembly and all those stuff, or low-level programming language, while high-level programming languages are Python, Java, and all these modern programming languages which we use nowadays. And machine code is nothing but binaries, which is zeros and ones. So high-level programming languages are developed by keeping the low-level programming language as the base. So in Python there are combination of different type of other high-level languages and of course low-level languages together, and on top of that Python is like a feature-rich programming language where you can directly implement any type of application or modify it according to your particular project or program. It is ranked as the #1 popular language according to Tyobe index. So it's nothing but Python is, as you all know, Python is very familiar and it's very famous just because of its simplicity and its versatile nature, and it is suitable for creating machine learning programs, training artificial intelligence, and not only that, we can even do web applications, drivers. I think drivers are not made from Python, but other type of automations can be done easily through Python because of its versatile nature. Python drives innovation across AI, data science, and web development with an estimated 15.7 million developers globally. So as we know, Python is widely used in different type of industries and fields. Not only that, even Python is even used in astrophysics and other stuff, which involves a lot of calculation and simulations, which can be easily done through Python. And we have seen that we have an estimated amount of 15.7 million global developers using Python. So the next thing is brief history from ABC to global phenomenon. So Python was developed by Guido van Rossum. Yeah, I don't know how to pronounce that. Guido van Rossum. Yeah, Python is developed by Guido van Rossum at late 1980s, and it was first released at CWI Netherlands in 1991, and in the 2000s Python 2.0 was released, which is the public release, and in 2008 Python 3 was introduced, and now currently Python 2 is discontinued from January 2020, and right now Python is, I think, 3.15 or 3.16, I'm not sure. It's near to that version is available to download as the latest release. So this is the timeline of Python's release cycle. Well, one of the main feature about Python is the readability of the code. If you look at the code, you can easily understand the logic and what's happening in your program very easily, while other programming languages require a little bit time for us to understand about its syntax and other stuff. And it's community driven, so it's an open source programming language, which means it is not under a single company or an individual. It's community driven, which means open source developers contribute every single year for Python, and to make it even more useful and feature rich, from extensive contributions to modern fosters who just gets the Python code and develop it according to their customizability and release it, and every single patch is being released in every updates of Python, and it is free and globally available. So Python is available all over the world, and also it is entirely for free. There is no charge in using Python, so that's also one of the main reasons why Python is considered to be the most demanded languages in the industry right now. So under the hood, the interpreter and execution. So Python is an interpreted language. So what is an interpreter? Interpreter is nothing but it works like a translator. So if you write code in Python, it gets translated into machine code with the help of interpreter. So if the interpreter is not there, then computer won't understand your Python code. even if you have coded rightly. But the interpreter's work is like a translator, so that's why it's called as an interpreted language. So when you install Python, you're not actually installing the language, you're just installing the interpreter and the environment where you can develop Python programs. And the next thing is no pre-compilation is needed. So in Python there is no pre-compilation is needed. What is pre-compilation anyway? So let's say you're developing your program, and in your program you gotta code a lot of function, classes, objects, and all the other stuffs have been pushed into the program. But when you're running the program for the first time, you don't have to compile a single module once and integrate it with the Python code afterwards. You can just run the module at once and it will be automatically compiled when the code is running for the first time, and each and every time the code compiles from scratch, line by line. So that's why Python is a line by line interpreted language. And it is also a disadvantage in Python because it just runs the code line by line, which slows down the output, while comparing to C or C++, which is not executing line by line, while Python does that. So that's a little bit of disadvantage in Python. Well, you may ask me, so if it is slow, then why people do often prefer Python? So it's not a big deal when it comes to production programmers, like all the public production programmers who develop and create software. But it's a huge disadvantage when it comes to simulation or machine learning or all the core operations or calculations which you do on Python. So it's a little bit of disadvantage for them. And the next thing is CPython is the standard implementation. So as I said before, Python is developed from other high-level programming language, so it is on top of the other programming language, which includes C and C++. And also you can even import C libraries or C++ libraries into Python and use it in your Python code. So it even supports C and C++ libraries as well. So it generates bytecode. So bytecode is nothing but it's like the code which is generated by the compiler and which is not executed directly into the computer, but it is created for supporting the code that you have made, and this enables faster execution. As I said before, the execution is done line by line, and with the help of bytecode, the execution is made a little bit faster comparing with without the bytecode. The next thing is global interpreter lock, and this impacts multi-threading. So this is nothing but in Python, if a process is generated, if a process is initiated, it just focuses on the single process which is being executed, and it cannot focus on other multiple processes or other tracks simultaneously, which impacts multi-threading as well, which is nothing but it can only focus on a single thread and solve that problem and move on to the next one without solving it entirely simultaneously. Versatility in action, key applications. So this is why Python is called as versatile programming language. It can be used in any type of applications like web apps. So before web apps, we all know Instagram, right? So it was developed with Django. So that's how not entirely with Django, but Python Django is used in Instagram, and Flask is used in Netflix. So all top MNCs use Python nowadays for supporting their software, and frameworks like Django or Flask are used to develop web applications. And data science and AI, so libraries such as NumPy, Pandas, TensorFlow all are used for data science and AI. So NumPy and Pandas are data science libraries. You can do numerical operations, and Pandas is used for getting the analytics and analyze the data and all those stuff. TensorFlow is like it's used for train your model, train an AI agent, all those stuff, which is being used in Google and NASA, of course. And automation and scripting. So if you are a if you are a DevOps engineer or system administrator, and you cannot keep on doing tasks repeatedly and manually, all those tasks can be easily automated with the help of Python. And by writing a simple Python script, you can automate any type of task which is possible. And scientific computing, as I said before, Python is used for many type of other scientific needs, such as astrophysicist, and matplotlib for academic research, which is matplotlib is nothing but it's like a library which is used for visualizing a given data or a set of data. And the next thing is desktop user interface. So you may have seen in supermarkets or any type of store which you visit, they'll be using the barcode scanner, and they will have a customized software for the building purposes only. So all those things can be easily achieved with Python, so in which we can use PyQt and tkinter for cross-platform applications, which is used for developing graphical user interface. Future is Pythonic. So Python is keeping on dominating AI, ML, data science and data analytics industry for a pretty long time, which is being expanded to IoT and edge computing, and which is easy to access because of the easy and simple syntax, which is very easy to understand, and it remains vital for modern technological innovation. So if you are creating a new technology, Python is suitable for it to be as the foundation for your technology. So in this session, in this module, we saw some of the information and the history of Python, and in the next module we're gonna see how to install Python and set up a developer environment. We're gonna start coding from the next module itself. In this module, we're going to see how to install Python and an IDE, different types of data types in Python and variables, input and output statements, commands and indentation, and typecasting. So without any further ado, let's get started. So I'm inside my Ubuntu system. So this is a Linux based operating system. So basically Linux comes with built-in Python. So let us check whether I have Python installed on this system. So Python is not installed, like the path is not installed. So let me just install Python. Sudo apt get install Python is Python 3. You can install Python if you're using Windows. Just go on to a browser and type Python download. This is the official website of Python. Go ahead and download your latest version available. So I have the 13.13.5 as the latest version. When you click that, it will be downloaded as a tar.exe file for Linux. But if you are using Windows, then it will be downloaded as an exe file, or if you're using Mac, then in that case it will be downloaded as a pkg file. And from this page itself, we can download for both Windows, Linux or Unix systems, Mac OS and other operating systems as well. We can also download it as Docker image and install it on our system. So I have installed Python in my Linux system, and now after installing Python, we'll be needing an IDE. So basically, if you're installing Python in your Mac or Windows machine, you'll be having a software called as IDLE. You can go ahead and search for IDLE on your Windows or Mac machine. But since I'm using a Linux, I have to install IDLE manually. So let us go ahead and install IDLE. In Windows or in Mac, IDLE will be coming as a pre-installed package when you install Python. So you can use IDLE to learn and train how to use Python, or even you can develop simple programs in Python, but it's not a full-fledged IDE, since IDLE stands for Integrated Development and Learning Environment. You'll be needing an IDE called as Integrated Development Environment. So let us go ahead and search for IDLE, and we have ideally installed on my system. So this is how ideally looks like. So basically this is what you call as live mode. So in live mode we can execute simple commands, and that will be executed as soon as we hit enter. For example, let us say I want to add 5 plus 5. So 5 plus 5 is equal to 10, just like that. Not only that, we can even do multiplication, like for example like that, or we can do division as well, just like that. And not only that, as I said before, we can execute live commands. For example, let us print hello world in Python. So this is how we print hello world in Python. So we gotta type print with brackets, and with the quotation mark we can type whatever we want in this, and when you hit enter we can see hello world is printed. So this is what you call as live mode, and ideally has a different type of approach called as script mode. So we can go into script mode by clicking on file and new file, and this is what you call as script mode. Since when you hit enter, the previous line will be executed as soon as you hit enter. If you want to store multiple lines together and print it together, then in that case script mode will be your ultimate option. But the main disadvantage in script mode is, or in ideally in common, is it does not have autocomplete, and it doesn't show you if you are facing any type of error, or if you are typing the code wrongly. In that case we'll be needing an IDE, a full-fledged IDE, and most commonly used and beginner friendly IDE for Python is called as Pycharm. You can go ahead and download Pycharm from JetBrains official website, and Pycharm basically has two mainly used versions. One is for professionals and the other one is called as community. So the community edition is completely free. You can download Pycharm community edition from JetBrains website. So this is Pycharm, and we can download the Linux file, but I use Ubuntu, so we can download directly from the terminal. But in Windows or Mac you need to download the setup file and install Pycharm. So let me just install Pycharm in my system. Okay, so Pycharm will be installed in my computer very soon. So in Pycharm, this is what a basic IDE looks like. Even if you're using Visual Studio Code or let's say whatever text editor or IDE you take, this is the basic layout. So if you're practicing to develop full-fledged software or program, then I prefer you using Pycharm. And if you are okay with using VS Code, we can even use VS Code. But for the sake of this tutorial, this is for beginners, so we are going to move ahead with Pycharm. So it's downloading. So Pycharm is installed in my computer, and now we can open Pycharm by going into our application menu or start menu if you're using. So this is Pycharm community edition. This is completely free, and let's open that. There we go. I confirm and click on continue, don't send, and there you go. So this is the opening interface of Pycharm, and in this we can go ahead and click on create a new project for our testing and development purpose. So I'll create a new Python project. We can select the Python version which is installed on your system. So by default I'm using Python 3.12. this is what it came with my operating system. So you can select your latest version available, and then just click on create, and once you do that, it will take some time to create the Pycharm project. Okay, so the project is created. Now what we're going to do is we're going to click on to this folder right here. So this is our home folder, and in the home folder what we're going to do is we're going to click on plus Python file. I'm going to name the Python file as main.py. So the main.py is the Python file which is going to be your main application or programs window. So we should be able to execute every single screens separately with the help of main.py. From this main.py we can start typing the code, but before that let me just take you through the interface of Pycharm. So this is your text editor. In this area you will be typing your code entirely, and on the left hand side we can see all the files and the directories available for our project. And this is our home directory. As I said before, our project files will be stored in this directory, and this .venv file is called as virtual environment folder. So let us say you're installing a library or particular package in Python, and before installing it and using it in our system, we don't often download those packages directly into our system, because some programs require older version of a library, some programs require newer version of the library, or some programs don't have to change any type of versions when it comes to library. In that case, VENV or virtual environment holds your hand, and in that case it will just download the library only for this project. So if you're creating another project and which uses the same library, you'll have to download the library once again for that project, so that if you miss something in this particular project, then you can just delete this venv file and create a new venv directory and install libraries in that. And these are the external libraries folder, and we have some scratches and consoles. This is not required for us for this session. And this is our project toggle. So this shows and hides the sidebar, and this is the structure of the project, which is nothing but if you are having multiple files which is being imported into each one of them. In that case, we can see the structure together to see and analyze whether we have created a project which works or not. The next thing is these are some other options for Git and bookmarks, find, run, other stuffs like that. And we have a Python console over here. So this is the console which you see on IDLE live mode. So we can execute stuff like that. You know, it works just like IDLE. And then we have Python packages. So this shows all the packages available. So you can even search for a package and install it from here without actually installing in your from your terminal. We have services, we have terminal window for which opens the virtual environment in our in your console. You can install pip packages from this, and we have problems, we have Git version control, all the other stuff over here. And on the top corner we can see we have a run option. We have the current pointer where which file should run. We can select and edit configurations from this option. We have a debug option here, and we also have other options such as AI or signing in with your account, search option, settings, and other stuff like that. So without talking much, let's get right into the coding part. So let us start with the first concept, which is variables. So variable is nothing but, let us say name is equal to Siddharth. So in this case, name is what you call as the variable. So when you print the name, in that case this will be printed in our console. So let's check that out. There you go, just like that. So this is what you call as variable. So wherever you want to pass this particular string, in that case you can pass this variable onto there. So this is what you call as variable, and variable can be in any data type. So before that, let us check out all the data types available in Python. So let us go with the first one called as integer. So integer is nothing but a number value. So this is going to be a whole number. There should not be any type of point values or decimals which is present in this integer data type. So With for this integer we don't actually need the quotations, but we can just directly execute the number. We can directly type the number just like that. The next thing is float. So float is a data type which has decimal values. For example, let us say 3.14. In this case, this is a decimal value and the data type is float, just like that. So from this we can even see the data type printed onto a system. But before that, let's proceed with the other data types as well. Next thing is string. String is nothing but alphabetical values. So let us say string is equal to hello. So in this case, strings are the ones which should be coming into this quotation marks, and inside that we can type hello, or if we even type a number, that will be stored as a string because it is coming under a quotation. So hello. And then the next thing is Boolean. So Boolean is nothing but true or false values. So let us say we have a true value here, or we can even add false value here. So this is used as if or not, try, catch, or any kind of logics can be executed with Boolean. And of course, true or false should be executed with the starting letter as caps. So this is a basic logic. So let us make it as true for now. And the next thing is list. So list is also a type of variable, it's a type of data type in Python. So let us type list variable is equal to, and list can be executed as square brackets like that. So we can type numbers in this, or we can even type strings in this, just like that. So this is what you call as lists, and we can print any one of them just by typing a simple print statement. So let's start with integer, and if we run that in our console, we should see 10. Same thing applies for float, string, boolean, and list. So let's go with float, and let me just print all these things one by one. So integer, print string, print boolean, print list, that. Good. So if we print that, we can see all these values are printed in our console, just like that. Some other data types such as tuples. So tuples is also just like lists, but it has a main difference. Let me just show you. So this is what you call as tuple, and in tuple we can see in the list we are using square brackets, but in tuple we are using round brackets. But why? Well, list and tuples are similar, but the thing is, lists are mutable and tuples are immutable. What's mutable and immutable? Well, let us say if we want to add a value to list with our program, let us say we want to get an input, and if we want to add that to the list, then in that case that value will be added into the list. But you cannot do the same thing in tuple, because in tuple you cannot add values, we cannot edit that values programmatically. So that is why it's called as immutable. And some other data types such as dictionaries is also available in Python. So let us create a dictionary now. So dict1 is equal to, let us store values such as we should have a key and a value. So in this case, in dictionary what you call is, let us say it has two different types of variables, and if you call the key, the value for that particular key will be printed. So let us say the name, and the name is Siddharth. In that case, when you print the name in this, then the value for that particular key will be printed, which is this value. So this will be printed. So that's what you call as dictionary. The other thing is, let us say we also have a different type of data type called as none. So none is nothing but, let us say, none is equal to none. So this is a none value, which means if you have nothing to fill in a particular place, or if you want to fill a raw or dummy data onto a variable, then you can pass this none value over here. The other values such as set. So set is just like it's also similar to tuples and list, but a set is different from both of them. So it will be considered with curly braces, and we can type the values just like tuples and lists. So this is what you call as set. Now we can see that these are the different types of data types available. Now let us proceed with input and output. So input and output statements in Python is also one of the most common statements and common usages in Python. So let's proceed with one of them. So I'm gonna ask you, what is, in the quotations, let us ask, what is your name? So I'm gonna ask you this question. So if we run this, then the question will be asked, where will you type your name? That's the question here. So that is where the input statement comes in. So let us type an input. For example, name is equal to input, and the input will be enter your name. And if we type that, then a print statement comes. Oh, and before that, let's add a f over here. It's nothing but it's a formatting variable. So hello name. So let's run this. Enter your name. Oh, hello Siddharth. It's just like that. So now we can see that we are entering the input statement. But the thing is, by default, when you enter input in Python, it will be stored as a string value. But what if we want float value or other data types? How are we gonna do that? It's very simple. Watch this. So now what I'm gonna do is, I need a program where I can add up values. In that case, what will I do? So you can pause the video, and if you know the answer, you can try it out, or let me just show you. So in that case, what we're going to do here is, we need to create two numbers variable here. So num1 is going to be one number, and the default data type, let's make it as a default input. Okay, enter the first number, and if we print the type of num1, that is the type a number here, so 5. So 5 is considered as a string, but we cannot add a string. Let's try out. So let us add num2 input, enter the second number. So now what we're going to do here is, instead of typing the instead of printing the type of the variable, let us just type num1 plus num2. In that case, if we run the program, we have a number here. So it's the first number is 5, second number is 2, 52. But why? We need to add the values, right? So that is where the different type of data types and the input comes together. So we can type an integer input where we can enter an integer as an input and process and give you the output. So let's do that. So int and close the brackets just like that, because in the integer data type, the first bracket will be closed here, and the inner bracket will be closed here. The second data type is also an integer. So in that case, we can just go ahead and execute the file. So the first number is 5, second number is 2. There you go. So now the values are added. So this is how different types of data types comes into the play. Now this is a basic input and output statement in Python, and let us go into the commenting and indentation of Python. Okay, so what we're gonna do here is, let us create a simple comment here. For comments in Python we can use hashtags. So in hashtags we can type this is a comment. So in this line, if you just hit enter, you'll be coming back to the coding environment. So this is a single line comment. But let us say you want to type a larger lines. Let us say you want to type multiple lines of comments. We can just hit hashtag once again and type it, but it's a bit hard, right? So that is why multi-line comment comes into the play. So multi-line comments can be done easily by typing double quotations 3 times, and in that case this is a multi-line comment. So we can type infinite number of lines between these quotations over here. So this is how you type multi-line comments in Python. So comments are nothing but this is for your reference in the code, and these lines will not be executed when you run the Python program. So now let's look into different types of operators in Python, which includes all the arithmetic operators and comparison operators. So let's get started. So first I would like to show you different types of arithmetic operators in Python. So let's do that. So what I'm going to do here is I'm going to create 2 variables with integer values. So I'm going to create a is equal to 10 and b is equal to 3. In that case, when I just print the values, let us say I want to print a and b together. In that case, a plus b. So now this value will be added up to this value and print 13 as the output. Let's see, 13, just like that. So this is for addition. What about subtraction? In that case, what we're going to do here is, let us proceed with print a minus b. Alright, in that case, when I just hit run, there we go, 7, because 10 minus 3 is equal to 7. What about testing the multiplication in this? 10 3s are 30. Let's see whether it prints it or not. Print a multiplied by b. So for multiplication we use asterisk. When I print that, 30. Alright, just like that we can do division. Division can be done using a / b. So 10 divided by 3 is equal to 3.33, just like that. Not only that, we can even do float division in this. It's just similar to division. We can do that by typing print a / 2 times b. In that case, we can see that there we go, float division. What about modulus? We can even do modulus in Python. For that, we can type print a % of b. In that case, it will print us the modulus. So let's check that out. There we go, modulus of 10 and 3. What about exponential? For example, the power factor. In that case, we can denote power in Python by typing 2 asterisks b, which means it will be as 10 to the power of 3. Alright, so let's print that. There we go, 1000, just like that. And let's move on to comparison operators. Comparison operators are just like this arithmetic operators. But the thing is, we don't perform anything in that newly. We just compare between two variables and print the output. That's what we do here. So let's just take down all these things and let's proceed. So for comparison, what we do here is, let us say if A is equal to B, in that case print true. Alright, so if A is equal to B, then print true. But why there is two equals here? You may ask me, well, why there are two equal? Well, the thing is, if we type one equal, then that will be as the declaring sign, which means for variable the value for B is 3. So that's why we're declaring 3 as the value for B. Meanwhile, two equal signs represent comparison, which means we compare whether the values of A and B are same. Okay, and we'll be covering if else elif statements very soon. So for the sake of this explanation, I'm typing if else. So print false. Okay, so now let's type and let's just run the program. False. Why? Because it is A is not equal to B. Okay, let us say A is not equal to B. In that case, what we're going to do? So how do we type A is not equal to B? It's very simple. Type an exclamation and equal. So this represents not equal to sign. Alright, let's run this. True. Alright, because A is not equal to B, because 10 is not equal to 3. Right, now let's proceed with greater or lesser signs. In that case, what we're going to do here is, let us say A is lesser than B. Alright, if A is lesser than B, print true, else print false. So let's run this script. False, because A is greater than B, it's not lesser than B. Now let's change the sign into greater than B. Now if we run the program, true. Right, now let us say I want to check whether it's equal or greater or equal or lesser to B. In that case, what we will do is, we just add another equal to between this part. So after the greater or lesser sign, we add an equal to, which means it will see whether the value is greater or lesser, or it is equal to A or B. In that case, true, because A is greater than B. Or let us change A value to 3. In that case, true, because we have greater or equal to symbol. For lesser or equal to, it remains the same. Just change this value to lesser symbol. In that case, it is it will check whether lesser or equal to B. Alright, so this is simple comparison operators in Python. Alright, and indentation. So Python is an indentated programming language, which is nothing but it should be aligned perfectly with each single line coming down. Let us say you want to create a function. For example, def is where you will be creating a function. We'll be covering functions later, but for the sake of this indentation stuff, I'm going to show you how to cover or how to declare a function and cover the indentation. So let's create a function called as greet. In this case, what we're going to do here is, message is equal to hi. Now print message. So if we pass this function over here, we can see hi is printing, because that's the message that is what we are giving as print. And when we pass this function, these lines will be executed, right? But let us say I have one more space in this. Okay, in that case, will it run? Yes, it is running, but it is not aligned perfectly. Let us make it as all aligned together. Let's all face everything to the wall.
In that case, we already see we can already see that we are having an error here. So if we run that, we get an expected indented block after function definition in line 1. So that is why indentation is important in Python, right? So this is what you call as indentation. So in this module, we have seen about how to install Python and how to install different types of IDEs and all the data types, all the commonly used data types available in Python. We have also seen comments, multi-line comments, and we have seen indentation, and also we have seen input and output statements together. So this is the end of this particular module, and as I said before, I will be giving you simple projects to try out in the end of each module. So for this module, I'll be giving you a project to develop a simple calculator, which is nothing but you should ask the user for 2 number inputs, 2 integer inputs, and you have to print the sum of 2 values and the product of 2 values and the subtraction of 2 values. So you will be printing all those values one after the other. So that is your project, that is your activity for this particular module. And yeah, I'll see you guys in my next module. See you soon. Welcome to the third module of this course. In this module, we're going to see about control flow in Python. So in this module, we're going to cover topics such as conditional statements, which includes if, else, and elif statements, and Boolean logic. We're going to see about loops. We're going to see about break, continue, and pass statements, and then we're going to have an activity session where I will give you a program which you should code by yourselves. Okay, so in Python we have if, else, and else if statements, just like in Java or C, C++, but instead of else if, we will use elif. So let us start by creating a variable called as x, and let us give it as and let us give 10 as the value for that. Okay, so x is equal to 10. Now if x is greater than 0, then print the number is positive. Elif x is equal to 0, print the number is 0. Else print the number is negative. So this is a very simple syntax. As you can see, we have gave the value x to be as 10, and we are starting with an if statement, which is nothing but if x is greater than 0, the number should be positive. If x is equal to 0, then the number is 0. We all know that. And if the number is not greater than 0 and it is not also 0, then the number should be negative, right? So in that case, the number is negative. And here we are using elif, just like else if, which we use in other programming languages, right? So let us start by running this program. So the number is positive. The reason is it is greater than 0. Let us modify this code and get input. Okay, so int input, enter a number. Okay, so now let's just run this. Enter a number. I would like to enter 5. Number is positive. Let us say minus 12. Number is negative. And 0, number is 0. Just like that. So this is a very simple if, elif, and else statement. You can try this on your own. And now let us proceed with Boolean logic. So Since I said before in the previous module, Boolean logic is nothing but simple true or false, right? So let us say A is equal to true and B is equal to false. So this is nothing but we are storing two Boolean values in variable A and B. Alright, so if A and not B, print Boolean logic A is true and B is false. Alright, so let us try this out. There we go. So what we're doing here is, so A is true, B is false. So we're comparing A and B, and if A value, which means if A is true, then B should also be true, and if you're checking if it is not true, so that's why if A and not B, then we are printing Boolean logic A is true and B is false, right? So this is simple Boolean logic, and we can also do some interesting stuff with this. It's up to your creativity. However, you can share your own code and projects onto my link as GitHub repository, and I'll review it in my YouTube channel once. Okay, now let's proceed with loops. So in Python we have two types of loops, for and while loop, right? Basically, for loop is nothing but it has a range, which means it should have a starting point and an ending point as a range, and it won't go beyond that. So that's why we use for loop. While loop, on the other hand, it does not have a range, which means we often use while loop for a conditional statement or a particular condition to be satisfied. Until the condition satisfies, the loop will not break. But once the condition satisfies itself or a particular condition achieves from the loop, then the loop will break and come out of it. Alright, so that's what we're going to see now. So let's proceed with for loop. The basic syntax for a for loop is very simple. Watch this. So for I in range, and we have to set a range. Let us say 3. Alright, so 3, print. What we're going to do is we're going to print the I values, right? So, or else we can simply just type I. Good. So there we go. So what's happening here? It's very simple. Basically, this is the structure of for loop. So we are starting a loop, and I is going to be the variable, and we are setting a range. So for I in range, and in that range we are setting 3 as the range. But the thing is, the starting point will be remaining as the value 0, which means it will start from 0 until it goes to 3. But the thing is, it does not denotes the index value. Alright, so this denotes the number of values, which means we have 3 number of values as total. Let us say I set 1 as the starting point. Okay, so from 1 to 3. In that case, if we run the code, we only get 1 and 2 because the range is 1 and 2. But the default value is 0, right? So that's why it starts counting from 0. But we are setting 1 as starting point and 3 as ending point. So that's why it is going just between that. Alright. And this is the basic functionality of a for loop. Also, for loop can be used in other data types also. For example, let us say we have a list. So we create a list, and I would like to create a list of fruits. Okay, so I have created a list of fruits, and now what we're going to do here is we're going to set the range as the list. So we're going to pass that list. Okay, for I in list, we're going to print the I values. So let's just print this. As we see here, we get all the values printed because we don't have any range set here. Let us set a range, for example. So I would like to set a range for let's say I think I cannot set a range. So as you can see, the values are printing, right? Because we don't have a range and we have the range passed as list here. So the fruits are printing in the list, and that is the I value, which means each of these values will be stored in this I, and that will be printed over here, right? So this is how it works. Now let's move on to while loop. While loop is also the same syntax but with the minor changes. Watch this. So what I'm going to do here is let us say let's create a counting loop. Okay, let's create a count while loop, and for that what I'm going to do is we're going to create a variable called as count. Count is equal to 0. So when we print count, it will be returned as 0, right? But let us say that I want to increase this count value up to a level. Okay, in that case what I'm going to do is while count is lesser than 3. So while count is lesser than 3, what I'm going to do is print count. In that case, when I run this, the code will start running infinitely, but I don't want that. I want to stop this, right? So in that case, I want to add 1 to each of this iteration. No, every time it loops, I have to add 1 value to this variable. So how am I going to do that? It's very simple. So what I'm going to do here is we're going to go ahead and type count plus 1, which means we're going to add 1 to each of this count. So that's what we're going to do now. Let's do that. So if I just click on run, we can see 1 to 0, sorry, 0 to 2. So how this works, let me break down. So by default we are initializing this integer value of 0, right? The variable, the value is 0, and now while count is lesser than 3, what happens is it will print the count and it adds the value. Let's go one by one. So this is 0, it is lesser than 3, it prints 0 and it adds 1 to the 0, which becomes as 1. Now the loop continues. So 1 is lesser than 3, it prints the count value, count plus 1. So 1 plus 1, 2. So 2 will again loop into the while loop, and in that case it will go ahead and add 1 until it becomes as 3. So 3 is not lesser than 3, right? In that case the loop will break. That's what is happening here. Let's make it as 100, for example, and if we run that, there you go, we have printed till 100. I mean until 100 reaches, because once 100 is reached, then it will break. Alright, so this is while loop. Now we're going to see about break, continue and pass statements. So what are those? It's very simple. Okay, so basically you'll be using them in if, elif and else statements. Okay, so let's go with that. So let us create a for loop for now. For I in range, I'm going to set the range as 5, okay, which means 0 to 4, and I'm going to create an if statement here. So if I is equal to 2, in that case I want to continue. Okay, if I is equal to 4, in that case we'll break the statement. Okay, and then if I is equal to 1, we will pass the statement. Finally, for this we're gonna print loop. So we're gonna print the loop I. Alright, so what's happening here? Let me break down. So we are starting from 0 to 5, and if the values reach 2, it will continue. So what happened is it won't print 2. Alright, so it will skip the 2, then it will go to 3, right? But we don't have any statements for 3, but we have statements for 1 and 4. So when it comes to 1, before 2, in that case it will pass, which means 1 will be printed here, and it does nothing else. It will be just passing it. But you may ask me, well, we don't have to put pass here. Let's just get that out. But we get an indentation error, because whenever we use an if statement, we have to pass something inside the if statement. We cannot let it empty as that. So let's add pass here. Okay, so 1 will be printed, 2 will be skipped, 3 will be printed, and at the 4 it will break the entire loop. So shall we test it out? Here we go. There we go. So 1 is printed because nothing happens here, it will pass, and in 2 it skips the part, and 3 is printed because there is no statements for 3, and in 4 it breaks it. So in the point 4 it breaks the entire statement. Even though if we increase the range, nothing happens because we have statements here. So this is the conditional statements in Python, Boolean logic, loops, and other stuffs. So now we have come to the end of this module, and I would like to give you a task. So I want to give you a task to I want you guys to initialize a list full of integers, random integers, and then with that I want you guys to print the number of even numbers in that list. Alright, I don't want to print the even numbers, I want to count the even numbers and print the total number of even and odd numbers in that list. Okay, and I'll see you guys in my next module. Until then, bye. Hello everyone, welcome to the 4th module of this course. In this module we're going to see about different types of data structures and operations which we can do with them in Python. So let's get started. So for the basics in data structure, I would like you to remind about lists, tuple, and dictionaries in Python, which I have said in the second module, right? So we're going to work with that only. So let's proceed. So the basic structure of list is, as I said before, we need to type a variable. Let's create a variable as fruits. Let's declare a list. I would like to create apple, banana, and orange. So now I have this list here. So this is this list will be stored in the variable fruits. So when I print fruits, it will print the fruits. Yeah. Okay, so let me tell you, what about if I want to add any other instructions or rules over here, or any type of string over here. This is just a minor topic which will be covered, so watch this. So I would like to add a string with this before the fruit get printed. Okay, so in that case, list of fruits. In that case, this will be printed. Alright, so first list of fruits will be printed and followed by the list itself. So let's print that. There we go, list of fruits, and the list is printed, right? And then in list we have something called as indexing, which means every single item in this list have different types of indexes, starting from 0 to 1 and 2. Now you may ask me, well, there is only 3 elements in this list, then why is there only 2 indexes in this? The reason is, index will be started counting from 0. So apple stays in the index 0. Alright, so apple will be staying in the index 0. So let's check that out. So I would like to print, let's say I would like to print the index of 1. So what remains as 1? So fruits, and to denote the index we can add another square bracket and put on the index value which we want to print. Now when you run it, we get banana. The reason is 0 1, so in the value of 1 we have banana, so that's why fruits is printing 1 as a single value. And not only that, we can even slice the list and print only particular objects in that. For example, I would like to print from the value of index 0 to 2. In that case, what happens is it will slice down the second value, which means the index 2. So let's check that out. There you go. 0 1 and 2 get sliced. The starting point is 0, 2 gets sliced because the ending point is 2. Alright, not only that, we can even perform iteration through the list. So how do we do that? It's very simple. What we do here is we used to create a for loop in this, and we can iterate through the entire list of fruits. Alright, so let's proceed. So what we're going to do here is let's create a for loop now, and what I would like to do is we're going to keep the same list of fruits here. So let's proceed by creating a for loop. Fruit as the variable for fruit in fruits. So we pass the variable into the list, and in that what we're going to do is we're going to iterate through the entire list. So let's print fruit. In that case, when you run the script, in that case all the values will be printed vertically. So what happens here is we have a variable called as fruit, and that fruit iterates through the list, and each value of that list is printed one after the other. The thing is, since it goes line by line, because it is being executed as a print statement and it goes on loops for the for loop, right? Because that's what we have declared here. So the next thing is we're going to look into tuples. So what are tuples? I've already explained that in the second module. Tuples are just like lists. The main common difference is they are immutable, which means you cannot change the tuple values or even add or remove any type of values inside tuple while the program is being executed. So what we're going to do here is let's create a new tuple here. I would like to create a coordinate as tuple. Let's create a coordinates as the variable and store values 10 and 20 inside the tuple. So in that case, when we print the value coordinates, the values are printed, right? Just like that. There's nothing we can do with tuples because we can do indexing, but the thing is we cannot add or remove any values in tuple. So let's move on with the sets. But before that, I would like you to execute the same type of thing which we did with list. I want you guys to practice iteration and indexing in tuples. Alright, so I'll give you some time. You can do this on your own, and I will be doing that in a moment. Let me do that for you once. What I'm going to do here is I'm going to type print kwargs, and for indexing we also use square brackets in this. Okay, so in that case 0, so the indexing is 0, so it will print 10. Let's test that out. 10. Same thing for iteration. So for quad in kwargs print quad. In that case all the values are printed vertically. Alright, now let's move on to sets. Sets is also a collection of data. It's a data type in Python. As I said before, let's create a set now. So I'll create a set called as numbers is equal to, sets are declared using curly brackets. Yes, so let's create a number list 4 5 6. Alright, so we have created a set. So now what we're going to do here is let's print it once and see whether it is printing in the correct format. There you go. Sets are printing, right? Now what we're going to do here is, let's proceed with the iteration part in sets. How are we going to do that? For num in numbers, print num. If we print that, all the values are printed vertically, as it said before, just like in lists and tuple, right? So now there's something called as set comprehension in list. So what's that? It's very simple. What we do here is, we used to have a condition stored in a single line, so that's what you call as comprehension in set. We can perform that in sets. Alright, so let's do that. So instead of collections by itself, we can add a statement in this. Alright, so we don't have to mention 1, 2, 3, 4, 5, 6 as separate numbers. We can just create a statement which generates these numbers. Alright, so let's try that out. Numbers is equal to, I would like to print x to the power of 2x square for x in numbers. Alright, meanwhile the number function should be existing here, so let's type numbers. So numbers, let's add the numbers. Alright, now if we print the squared values, okay, so this is an example of set comprehension. So let's try that out. There you go. It's very simple. So we are printing squares of all these values. Alright, now let's proceed. Let's move on to the next data type, which is dictionary. I have mentioned this in the module 2. Now let's proceed with the data structure. So now what I'm going to do here is, we're going to create a data for a person. Alright, so person is going to be the variable. Person is equal to curly braces. I would like to store name, and the name will be, let's say, Adam. Alright, and the person's age will be, let's say, 20. Alright, so now if we print the person, the dictionary will be printed. Alright, now we're gonna look into iteration. How we're gonna do that? It's very simple. Just like in list and tuple and set, we can iterate very easily by typing key and value as the integer, because we have two values here. Alright, so one is key and the other one is value. How are we going to iterate this? Very simple. Watch this. So now what I'm going to do here is, in person, print format key and value. So now let us run the file. Okay. Okay. Alright, so we need to add something called as items here, because we are iterating through the items of this list, right? So let's do that once more. There you go. So the values are printing vertically because it iterates every single time it goes through a set of value, right? Now let's go into indexing. The indexing part is very basic in this. Okay, all we used to do is, we used to call out the key and it will be printed as the value which is paired with the key. Let's try that out. So print person, and with the square braces I would like to add name as the parameter. Now if I run that, Adam is printed. Alright, just like that. There is also dictionary comprehension available, just like in set. How we're gonna do that? It's very simple. Now what I'm gonna do here is I'm gonna create a variable called as doubled. Doubled is equal to curly braces k colon v to the power of 2. In that case, what we're going to do here is, if k is equal to age, else v for k, v in person dot items. Alright, so now if we run this script, let's print that doubled value once again. There you go. Now we can see that all the values are doubled, because what we're going through here is the age is denoted by k and the k is doubled, sorry, the v is doubled. Alright, so the value is doubled because we don't want to double the k because it's a string. Meanwhile, the value for the age key is integer, so we would like to double that. So that's why we're multiplying that with 2. So 20 is doubled and now we get the output as 40. Alright, so this is what you call as dictionary comprehension. So now I would like you to work on an activity. I want you guys to create a dictionary which stores students data. Alright, and I would like you to print that data according to the students' grades, from the least to the highest grade. And with that, we have came to the end of this module, and I'll see you guys in my next session. We'll meet you soon. Hello everyone, welcome to this module of this course. This is the first module of this course, and in this module we're going to see about how to define and call a function. We're going to see function parameters, return values, scopes, different types of scopes like local and global. We're going to see lambda functions. We're going to see a star args and star kwargs. So let's get started. So what we're going to do now is we're going to see how to define a basic function. So let us proceed by creating a function. So to create a function in Python, we use this identifier called as def, and then with this keyword we're gonna type the name of our function. Let's say I want to name my function as greet. So while calling this function, we have to do some action, right? So in basic, function is nothing but it's a block of code which has several operations which is pre-coded into it. So when you call the function, that lines of code will be run automatically according to your parameters or conditional statements which you have entered in your code. So that's what basically function does. So instead of typing line by line, you can store your concept or your operation inside a function, and you can call the function, and that will be executed whenever you call that particular function. So here in this def greet, which means the function name is greet, what we're going to do is we're going to add some action. So make sure that you have indentation of 4 spaces here, because whenever the indentation is aligned perfectly, the code will execute without any errors. So as you know, in Python we don't use the curly brackets, and because in Java or C, C++, in every other programming languages we use curly brackets or even the regular brackets which we use. But in Python we don't use that. In function, we define the function by using a colon. Alright, but how do we define the operations which are inside the function? So for that we use this indentation, this space right here. Alright, so now let's proceed. So what we're going to do is we're going to print a hello statement. So let's proceed, hello. Alright, so this is a basic function. So now how do we call the function? It's very simple. Just type the name of the function with parenthesis. That's it. So what we're going to do is we're going to run this script, and we can see hello. What happens if we don't call this? nothing happens, it just gives a blank output. So whenever you call the function, in that case only you'll get the output perfectly. So what we're going to do is this is our basic function. Alright, you can try this on your own. Now let's move a bit further. Let's add input to this function. We can directly add input to this function, right? But what happens if we want to process different types of data in the same function? For example, let me show you. I'll just go ahead and add an input to this function. There we go. So hello, let's put a format tag here and curly brackets here, and I would like to create a variable for this, and let's enter the variable over here. And now if we run the script, nothing happens because we have to call the script. There we go. Now if we call the function, we can see we have enter your name prompted here. So let's enter my name. Let's say Adam for an example. Hello Adam, just like that. Now this is a very basic input, right? But what will happen if you want to process multiple data? Will you have to just create multiple inputs in the same function? That's not how it works. That is where parameters comes to the play. So parameters is nothing but it's just like the input, but what we do is we initialize the variable within the function itself, which means we create the variable when we define the function in the def statement itself. Let me show you. So what I'm going to do is I'm going to write an addition function. Okay, so how we're going to do it? So first let's create two variables. So I'll create a variable here, y is equal to, let's say 23. Now what we're going to do is we're going to create a function for addition. So def add, we're going to name the function as add, and we're going to create two parameters here, so a and b. Alright, and now type a colon. We're going to just type print a plus b. Alright, now while calling the function, what we need to do here is we need to call this variables here. Alright, so x and y. Now in this point you can see that we have called x and y, but in the parameters we have a and b. So what is happening here? It's very simple. So let us take this as a template. Okay, so in this template we have a dummy variable called as a and b, and we are processing it inside the function itself. But while using this in our code, what we're doing here is we're working with x and y. So what we're doing here is we're just adding x and y. In that case, the templates will get replaced by this variable, which means according to the function, this x is equal to a and y is equal to b. Alright, so that is why when you type x and y inside the parameter, that will be replaced in this add function, and then with that values which is collected from this x and y will be processed in this part. So now let's just run this code. There we go, we got the answer. Right, so this is how it works. And not only that, while calling the functions, we can also input the values directly. Alright, so what we're going to do here is let's input a direct value. Let's say 5, 9. In that case, we can see it automatically adds the parameters, which means it is denoting the parameters. So a is 5 and b is equal to 9. So when you run this, we get 14 because the values get replaced by these variables. Alright, so let's move on to scopes. So what are scopes? Basically it's nothing but variable, but in the scopes, when you have a local variable, that variable will be accessed only inside the function. For an example, let's start with a basic function. So what we're going to do here is we're going to type x is equal to 10. Alright, so here for this variable, it's not inside a function, which means it's global, and this variable is accessible in all the functions which are defined. We can type any number of functions and all those functions can access this x variable because it's global, right? It's not inside the function. In that case, let's create a function here. So in this function, what I'm going to do here is, let us define another variable. So y is equal to 15. In this case, this y right here is a local variable, which means this y cannot be accessed outside the function. This can be accessed only inside the function. But what we can do here is we can even include this x here because this is a global variable. Alright, so let's try. First, what we need to do is we need to access this x. So for accessing the x, what we're going to do here is we're going to type a keyword called as global and x. So now this variable will be called inside this function as a global variable. And now what we're going to do here is we can modify this x variable, or we can do whatever we want with the x. Alright, so let's try. So let's just modify this x variable for now. So let's modify this into 20. Alright, so now x is equal to 20 inside this function. So when you call this function, x will be replaced by 20. But when you don't call this function, then x remains as 10. Alright, so now let's just try to print the values. So print x comma y. Alright, so now let's just run this code. Nothing happens because we need to call the function, right? So there we go. So here we have it, x comma y. The value for x replaced by 20 because that's what is called inside the function, right? So that is how you do it. So this is what you call as scopes. So this is a local variable and this is a global variable, but to use or modify this global variable, we have to pass this global keyword here, and after that we can do whatever we want with that variable, and we can process the variable in this function, or even we can access it outside the function because it's global, right? So this is how it works. The next thing we're going to see is lambda functions. So what are lambda functions? So when you look at this function, this is a general common function which we use in Python, but lambda functions are different from this. Not exactly, but lambda functions are nothing but short form of the functions, which means, as you can see, this is taking a lot of space and a lot of typings, while lambda function completes in one line. What I'm going to do here is we're going to go ahead and create a lambda function. So I'll create a lambda function called as square. So square is equal to lambda, and within this we can type lambda x is equal to, or with colon, lambda x is x asterisk x. Alright, in that case what we're going to do here is we can just print square. So this is the parameter, right? So what we're going to do here is we're going to pass this parameter with this variable, because this is what you call as the function. When you call square, then that function will be called. So let's pass the value for this x parameter. So let's pass as let me just open a parenthesis and pass 5 as the value. So x is equal to 5, so 5 into 5, the value is 25. Alright, so that's what you call as lambda function. So basically it's nothing but a function which is single lined, while a general function is multi-lined. Alright, so that's what you call as a lambda function. Now let us move on to the last part of this module. We're going to see about star args and star kwargs. what are those anyway? So let me just show you. So what I'm talking about is star args and star kwargs. So what are these? Let me show you. So args and kwargs are nothing but, we can add multiple positional arguments inside a function like a tuple, while star kwargs is nothing but it grabs a keyword argument into a dictionary. Alright, so it's like letting your function eat as many as inputs as you throw at it, which means you can we can enter any number of inputs inside a single input statement. Alright, so that's what you call as star args and star kwargs. So let me show you an example. Alright, so what we're going to do here is, let us say def, and what we're going to do is args and kwargs. Alright, args and kwargs, and in this way, in this function, what we're going to do here is, let's print. Before that, let me just add the parameter. So args and kwargs. There we go. Let's add the star also. Okay. So now what we're going to do here is, we're going to type print statement, and we're going to create args. Alright, and we're gonna print kwargs too. There we go. So now we can call this function. So args and kwargs. I have typed a W here. Let me just take that out. Done. So let's call the function and type the parameters. So I'm going to give the parameter 1 and 2, and these are args. Now name is equal to Alice, and age is equal to 30. So this is the parameter which we passed. Now let's just run this file, and there we go. As you can see, we are passing extra positional arguments, which is this 1 and 2, and we can shove a lot of inputs inside an input statement, or an argument is called as star kwargs. Alright, so that's what you call as star args and star kwargs. And I want to show you one more part in this module, that is return statements. So return statements are nothing but, it's just like print, but what happens is we actually end the function in that part. So let's create a function for addition just like we did before. So a comma b, and inside that what we're going to do here is, let's just define return statement here. So return a plus b. So what happens is, when you call the function and practice all the operations inside the function, the return statement gets completed, and the code for the function exits itself. So let me show you. So what I'm going to do is, I'm going to type a result variable. So result is equal to add, and I'm going to add 3 comma 4, and I'm going to print the result. There you go. So in that case, there you go. So in that case, what is the difference between a regular print statement or this return statement? So it's very simple. So in this part, this function is only defined for addition, and what we're going to do inside the function is also addition, which is a single operation, and for that we can use return statement itself. So it's not a big deal. So that's why for these minor usages we can use return, or if you're calling another function, or let's say you're going to complete your function, in that case you can call return statements. Alright, so now let's move on to recursion. What is recursion anyway? Recursion is nothing but calling a function inside a function. Well, let me show you. So I want to create a function for factorial. Alright, so what we're going to do here is create a test function, and inside this test function, if we can practice any type of operation here. So hello. So this is a common function. So when you call this function, what we do is we have to exit the function and call the function inside the file. Okay, but what if we call the function inside the function itself? So this is what you call as recursion. Let me show you with a quick example. We're gonna create a function for printing factorial of a number. So let's start. So def factorial, and the parameter is n, and then if n is equal to 0, return 1. Alright, or else we don't have to type else for this. Okay, so return n into factorial. So else is not mandatory in Python unless you need it. Okay, so n minus 1. Right, now let's just print, and we can call the function factorial. I want to print the factorial for 5. Alright, so there we go. 5 into 4 into 3 into 1 is equal to 120. This is the recursion, and I think we have completed all the things in this module. So that's it for this module, guys. I'll meet you guys in my next module. Stay tuned, and yeah, bye. Welcome to the 6th module of this course, and today in this course we're going to see about modules, pip, and how to grab an external package. We're going to see how to install Python modules and importing them. We're going to see some of hints of the most commonly used modules. We're going to see some of the pre-installed modules, of course. So without any further ado, let's get started. So in our Pycharm window, we can see this project folder icon. In some cases it will be open, and for some it will be closed. So when you click that, we can toggle this sidebar, and inside that we can see a folder called as .venv. This stands for virtual environment. So what's virtual environment? I have said this in the second module itself. Alright, so it's nothing but it's like a virtual machine. It's like a virtual device for you, which will work as a temporary storage for installation or importing your modules, like that. Okay, so what we're going to do here is we're going to start with a pre-installed module in Python, which is math. Okay, we'll see math in the coming up modules. So for now, let's just simply type import math. Alright, so the library math is imported now. With this library we can type let's say math dot square root of 16. Alright, so when you print that, we can see square root of math square root of 16 is 4.0, which is written as, so we can see that square root of 16 is 4. It is written as a decimal value. And what happens if we remove this line? It shows an error because the module is not imported. So we can type import math. Alright, so now we can see that it doesn't show any error. Just like that, we can import any type of inbuilt modules, or we can even install a module. Okay, I'll show you that later. Now let's see how to create your own module. Okay, so these are pre-installed modules which is already created, but the best part in Python is you can create your own module itself. Let me show you how to do that. So in our project folder, right click, new, and a Python file. I'll create my module called as, let's say, my utils. So this is our module. Okay, now let's just create a function here. So def greet name print, or let's just type a return statement. Okay, so return f for formatting hello name. There we go. So this is a module, and this is a function in this module. In the math module, this square root is a function. Okay, it is created in the math library, so that is why we call that function, and it is printing the values. Alright, so just like that, for in our module we have a function and an operation for that function. So let's do this. So now what we're going to do here is, let's just erase the slate and type import my utils. where did this guy come from, which is here. Alright, so we have imported myutils. Print. What we're going to print is myutils dot greet. How is it appearing? It is appearing from our module, which is this function right here. So who we're gonna greet? Well, so we'll just greet Alice for an example. Well, how did that work? Because we have declared a parameter here. Alright, so let's just run this code. Hello Alice. Alright, just like that. So that's how you create your own module. Now let us move on to installing external libraries using pip. Okay, so pip is nothing but it's a Python installer for installing external packages. Alright, let me show you how you can access pip. Is we can go ahead and open up a terminal here. Alright, so we can open up a terminal here, and or we can even have a graphical window where you can install pip packages only in Pycharm. But let's move on with command line. Okay, we have to practice command line for now. So in this part we can see our computer's name and the user and the directory which we are working in. Okay, so this is the directory, and you have seen this weird wording here. So what's that? Well, this is an indicator that shows that you are inside this Python environment. Alright, so whatever commands you enter in this window will be executed inside your virtual environment only. So let's start. Let's start by installing, let us say I want to install something called as requests. So let's install that. So pip install requests. So requests is an external Python library, so let's install that. There we go. Now it's installing. Okay, so it's successfully installed. So let's call that requests right here. So import requests. Alright, so request is installed. We have called that. So with requests, what we can do? Alright, so it's nothing but we can fetch APIs, or we can fetch data from external links or URL from requests. We can send requests to that URL or an API gateway using this request library. Let me show you. So I have imported requests, right? So let's create a variable called as response, and in that let's type requests library dot get. So get is a function in requests. Alright, so get, let us fetch something from GitHub API, but we're not going to use any API key. We're just going to get the URL. Alright, so api.github.com, and then here let's print the status. Alright, so the status is response dot status code. It shows the status of the fetching. So by default it will return 200, because when it returns 200, then in that case the connection is successful, which means we can access api.github.com. Here we can pass our API keys or something like that. That will show a different status code like 501 or 404. It depends. So let's just run this code. 200. How? Because api.github.com is accessible. So that's why. So this is what you call as pip installation. Now let's move on to standard Python libraries. So in our browser, just type PyPi. So this is the Python package index. So what is that? Well, it's very simple. Developers across the world or users across the world create Python libraries and modules and publish it in this Python package index. So pip fetches all the packages from here only. So when you type a library, for an example, I want to type random. So random is a library in Python. So random pip. There we go. Random. Well, random is a pre-installed library. Random 2 is a third-party library which a developer has been developed. So this is the developer status. and it is verified. We can see all the changes which has happened in the previous version of this module. We can copy this, because or else we can just type pip install random2 and that will be installed on our system, just like that. So we can browse any type of modules in this index itself. Alright, so that is for this module, and I would like to give you an activity. Alright, so what is the activity exactly? Use the random library itself, and I want you guys to create a guessing game. Okay, so what we're gonna do here is, I want you guys to generate a random integer starting 1 to 100 or 1 to 10, it's your choice, and then I want you guys to take input from the user and compare it with the integer which is generated by the requests library, and then I want you guys to show them that whether they have passed or not. Okay, I just want a guessing game, not like something like a hangman. Alright, just a simple guessing game, and I'll meet you guys in my next module. Bye. In this module we're going to see about error handling. What is error handling anyway? Well, you're writing a huge program, and in that case, when a simple mistake is occurred, your whole program will be terminated, and that's not what we want, right? We want to handle that exception and proceed with the program's other parts, right? For example, if you are getting an exception or if you're getting an error in a loop, in that case the program should skip that loop and proceed with the next part of the program. That's what you call as error handling. And in this module we're going to see about exceptions and different types of error handling, such as try and except, finally, else, custom exceptions, and also by the end of this module I'm going to give you guys an activity to do. So without any further ado, let's get started. So first we're going to see about a very common exception handling method which is called as try catch, or in Python we call it as try except. Okay, so how do we do that? It's very simple. Watch this. So I have a clean slate here, and in this slate I'm going to type try. So we're going to try to divide a number with 0. So let's type result is equal to 10 divided by 0. Alright, in this case we are trying to divide 10 by 0, and then we're going to type an exception for this, except. So there are different types of exception handling. So I'm going to type 0 division error. So watch this. Basically we are raising a 0 division error because we are dividing by 0, so it should raise a 0 division error, right? So we can type print can't divide by 0. Alright, just like that. So now in this case we can see that we are dividing by 0 and we are raising a 0 division error, and that will show us this output. So let's try it. See, cannot divide by 0. Let us just make it as 2 for an example. Now nothing happens. Or in this case we are trying to resolve the error, right? So this is how it works, but we have not got any output for this division because we haven't wrote any logic for providing the output for that. Alright, now let's move on to finally and else error. So else and finally are almost the same, but the difference between finally and else is finally runs no matter what grade for cleanup. Like for example, if you are running finally, in that case it won't check for anything else. If the finally statement is true, in that case it will run the operation directly without considering any factor, while else runs only if there is no exception is occurring in that particular operation or a condition. Let's say finally is like it can handle exception too, while else cannot handle exception. It will show you the exception itself. So let's try with an example. Alright, so let's try let's type try, and I want to give a variable number as the integer value, and I'm gonna type, let's say 1 2 3. So now we have a variable stored with an integer. In that case, we're gonna type an exception. So except, we're gonna type a value error. So print not a valid number. Alright, so this is an exception. Now let's type an else statement. So if this exception is not there, like we saw in the before case, if we want to print the output for that division, we can use this type. Alright, so now let's type an else print num. Alright, now here's where finally comes in. So finally we print done. So we are seeing that finally is nothing but it's like an all clear signal for your code. Like we show a try except error, and after completing all the exception or displaying the output, we show okay, everything is cleared in this particular try except function. So that is why we use this finally variable. So now we have seen why we are used finally. Now let's move on to custom exceptions. So what are custom exceptions? So here in this point we are used value error, right? While in the previous case we have used zero division error. So all these errors are pre-configured in Python. Not only that, if you are developing a huge software, you want to raise a custom error that only you can understand, or to make your users understand what's going on with your project. Alright, in that case you raise a custom exception error. So how are we going to do that? Watch this. So for this I would like to create a class. Okay, so class custom error. So class is nothing but it's just a pile of code which is which stores multiple number of functions inside that, and we can define a class, and we can integrate between classes. We can run and declare a main class, and that will be run when you run your program in the main Python file. Alright, so let's give the parameter as exception, and in this point I would like to pass on the arguments. Alright, in this case let us just create a simple function here. So def check age. Alright, so we're going to check for a particular age, and if age is lesser than 0, in that case we're going to raise a custom exception. Okay, so how are we going to do that? Raise custom error, open parenthesis, and type in your custom error. So age can't be in negative. Alright, now let us run a try except here. So try check age, we're gonna check age for -5, and then except we're gonna type custom error as e. So we're storing the custom error in this e variable, and now let us print e. Alright, so let's run this code. As you can see, age can't be negative because it's in negative. Let's go ahead with let's say 20. That case, there we go. So we have not got any errors, and that's what exception basically is. So we have seen some of the commonly used exception handling, error handling in Python. We have seen how to raise multiple errors, how to manage exceptions. We have seen how to raise a custom error, and that's it for this module. And for the activity for this module, I would like you to give a very small activity. So you have developed several activities. We have developed several programs at the end of each module. So I would like you to create an exception handling block for every line of code that you have wrote in the previous parts. Alright, I would like you to add exception handling to every activity which you have wrote before. And for submissions, you can use the link in the description box or the link which I will give anywhere. If you're watching this in Udemy, then I'll give it in the resources box. You can go ahead and submit your GitHub repository with all your activities done, and you can claim your certificate. And I'll see you guys in my next module. Until then, bye. Hello everyone, welcome to the 8th module of this course. And today in this module we're going to see about file handling using Python. So basically, what is file handling in Python? Which is nothing but reading and writing files or working with files. That is what you call as file handling. And today we're going to see a brief explanation about file handling, and today we're going to see about working with different types of files like CSV, JSON, TXT files, how to read and write those files in Python. So without any further ado, let's get started. So first, let us say we have a text file. So I want to create a text file in my area. Alright, so but we can just go ahead and click on new and click on file, and we can name a file with an extension called as txt and create a file, right? But what I'm trying to do here is we're going to create a file programmatically. How are we going to do that? Let me show you. So for creating a file, we don't have to import any library for text files. So what I'm going to do is, let us open a blank file. So with open, and I want to name my text file. So I'm going to name my text file called as let us say text file .txt. Alright, now I want to create this with the permission. So I want the permission to write this file. So for writing, we need to write W and then put a colon. But before that, what we want to do is we want to load this code into a variable, right? So we are opening this file and we want to load that into a variable so that we can work with that using that variable. How are we going to do that? Just type as file. That's it. So this is a simple method to open a file with writing permissions. Alright, so we have to write this file. So what I'm going to do is we're going to write a content to this file. So for that, file dot write, and in this we can either write something, or we can store a value in a variable and write that variable in this. Let's just write hello world, this is a text file written in Python. Alright, so now we have wrote the text file. Now what I'm gonna do is I'm gonna type file dot close. So what is close anyway? So we are opening the file, we are writing this text, and we are closing it. Alright, so now let us run this file and see whether the text file is created here or not. There we go, text file.txt. When we open that, there we go, we got our content written on this text file. It's just as simple as that. Now we have written this file, but let's say I want to print this statement by reading the file and display it in my output. How are we going to do that? It's very simple. So watch this. Now what we're going to do is, let's remove these lines. Instead of writing permission, I'm going to type reading permission. Alright, so we're opening this text file.txt as reading permission. Now what I'm going to do is we're going to create a variable called content, and we're going to read the entire file. Alright, so we're going to read the entire file, and we're going to print the content. Alright, so let us just run this file, and here we have it. This content is displayed from this text file right here. So this is for a single line file, right? If some file has, let's say, multiple lines just like this, in that case, if you want to read a particular line, or if you want to read line by line, we can customize this read operator, like let us say read line, or read lines for reading line by line. Alright, we can modify that accordingly. Now if we just run this once again, we can see the content is displayed here by reading the file over here. Alright, so this is how you write a basic text file in Python. Now let's move on to a bit advanced type of reading and writing. What about CSV? CSV is called as comma separated values. Basically it's nothing but the Excel sheet which you see on your computer, right? But instead of the extension Excel SX, I think so, instead of that we're going to use CSV, which is simpler and similar to Excel spreadsheets, but it will be separated using comma. When you open it on a text editor, it will be separated with comma, but if you open it with a proper CSV viewer, or even if you're opening that with Google Docs or Microsoft Excel, that will be displayed as a spreadsheet. So that's what CSV file actually means. So now we're going to create a CSV file in Python. But for writing a CSV file, we need to import the library CSV. So let's import that. Alright, so import CSV. Now let us create a new CSV file. So with open, just like we did on the text file. So let me create a CSV called as data.csv. Alright, with writing permission, and then what we're going to do is we're going to create a new line variable, and that's going to be null. So what's this exactly? So what this does is it creates a new line for each rows. So that's what it does. Alright, so new line as file. Alright, now what I'm going to do is we're going to create a writer variable for this. So for that, what we're going to do is we're going to create a writer is equal to csv dot writer. Alright, now in what we're going to write that? So we're going to write it in the file. The file is data.csv. So let's denote that here. Alright, good. So now we can just go ahead and type writer dot write row, and we can define row over here. So how we're going to define a row? It's very simple. Just type, let's say, name and comma age. Alright, but before that we want to wrap it up into a square bracket. Alright, good. So now we have written a row. Now this is what you call as a header row. Now we're gonna go ahead and write some of the other datas here. So write row, let's say Alice, and age is 25. Age is 25, and writer dot write row, and I want to create, let's say, for Bob. Alright, Bob is 30 years old. So now if we run this file, if we run this script, then a CSV file will be created. Alright, let me show you. There we go. When you open that, we have a CSV, right? So we can see that it is showing as a spreadsheet. When you click on the text mode, we can see this is how it looks basically. So we can see all the data are separated using comma, and this is how you write a CSV file. Let's say you want to display this data into your output. Just like in a text file, you can do the same, but there is a minor change in this. Alright, so what I'm going to do is we're going to go ahead and open the file. So with open data.txt, sorry, data.csv with reading permissions as file. Alright, Now what I'm going to do is we're going to create a new reader for this. So for writing we have created a writer. For reading we are creating a reader. CSV dot reader. What we're going to read is we're going to read file. Alright, now we're going to create a for loop in this. So for row in reader, so for every row in reader I want to create separate printing statements. In that case only each of the loops will print separately in different lines, because when you print a row or if you print a content, your cursor will automatically move down to the next line for processing the next data. Alright, so that's what it happens. So let's just print this CSV file. There you have it. All the data are printed just like we saw on this file. Alright, so this is how you write CSV file. Now let's move on to a bit advanced version of file handling, that is JSON. So JSON is like a universal language for structured data. It is commonly used and widely used among APIs, configs, and a lot of other structured data files. We can also store data in JSON and we can fetch them easily. It's one of the most flexible way that you can load up data and read them. Alright, so now we're going to create a JSON file. So for creating a JSON or to work with a JSON file, what we need to do is, so let's just import JSON into our Python file. Import JSON. Alright, now what we're going to do is we're going to create a data. So now we're creating a JSON file. Now we're going to create a set like structure for this data. So first I want to create name. Name is Alice, right? Comma, age is 25. So as we have seen from the beginning, while we are entering integer values, we need to make sure that it is identified as an integer, because when you identify integer inside quotations, that will be considered as a string, and we don't want that, because when you perform any arithmetic operation with that a particular integer, when it's quoted, then in that case it will be considered as a string and that will show you an error. We don't want that, right? So that's why we do this. So I want to create a collection called as skills. So let's create that. Inside quotation, let's type skills. And what are the skills anyway? I want to enter Python, and I want to enter JavaScript for an example. There we go. By the way, we don't want this curly brackets, we need the square brackets. Alright, good. Now let us open the file. So with open quotation data.json file, we're gonna create the permission as write. We're creating the file, right? So write as file. There we go. Write the content to the JSON file. What we're gonna do is we're gonna type json.dump. So what we're dumping? We're dumping data to file. Alright. So let's just run this Python script, and we can see data.json is created. When you open that, there we go. So we got all our data stored in the JSON file. So it's just like dictionary. We can access that with a key. If we access name, the value Alice will be printed. If we access age, the value 25 will be there. Alright, so this is how you store a new JSON file. Let's say you want to read the JSON file and print it. How are we going to do that? It's very simple. So what I'm going to do is we're going to open the same file. So with open data.json with reading permission as file. Alright, now we're going to create a new variable called as loaded data is equal to json.load file. So what's happening is we are loading the JSON from file, and we are reading the content, and we are storing it in the loaded data variable. Alright, now we're gonna print the loaded data. So let's just run this. There we go. So this is the JSON file. We have written a new JSON file using Python programmatically. Alright. So this is basically file handling in Python. And for the activity for this module, I want you guys to create a contact book. Okay. In that contact book, I want you guys to store and retrieve contact details from a JSON or a CSV file. Alright. And you can share those project links by uploading it to your GitHub repository and sharing the link to the link in description box down below, or somewhere if you're watching this in any other platform, it will be there where you can find all the links. Alright, so I'll meet you guys in my next module. Until then, see you later. And in this module, we're going to see object-oriented programming using Python. So this is like an introduction session for object-oriented programming using Python. And in this module, we're going to see about classes and objects, and we're going to see the init instance versus class variables. We're going to see about inheritance, encapsulation, polymorphism, and some other miscellaneous topics too. So without any further ado, let's get started. So first, I want you guys to remind you of the previous modules where I have used a class. Alright, so first I want you guys to understand what is class. So a class is like a blueprint. An object is the actual thing built from it. For example, let us say, think a class like a car design, and an object is the specific car that you want to drive. And with that in mind, we can easily understand what class does. So let us start by creating a class now. So class, just like I said, I want to create a class called as car. Alright, so this is the car design. Now we are creating an object first, but before that, a class should contain at least one function. So let's create a new function. So def, let's say drive and self. So that will be automatically entered. So what self does is, so this is just like a simple argument or a parameter which is nothing but it points to the same file. Alright, so which means it, as you can see in the explanation, parameter self of main.car.drive, which means it points towards this particular part. So that's what you call as self. So def drive, and in this function I want to just print, let's say car has been started. Alright, now let us create an object for this. So to create an object, let's come out of that class and create a new variable. So my car is equal to car. So this is my car, and to define the car design, like the basic template of that car, I'm pointing that to class. So this is an object. So let me just note that object, and this is the class. Alright, now we have to do an operation with that. So as you can see, we have only one function in this, so let's point that function first. Alright, so my car dot drive. So we are driving the car and the car has been started. So this is what we're gonna get. So let's just print that car has been started. Alright, so now you have a basic idea of what is car, what is class and what is object. Alright, so let's move on to init instance versus class variable. To denote init, what we type is, we type 2 underscores init, again 2 underscores. So what's init anyway? Init sets up a new object with initial data. So it creates a basic structure of the data. That's what init does. Init stands for initializing. Okay, then what is instance? So instance variables are nothing but they're just variables, but they are unique to each objects. Alright, so if you're having an instance variable in one object, then you can't access that in another object. And the third thing is class variables. So class variables is also variables which is accessed across all the objects. Okay, so if you're having a particular class variable in one object, you can access it from any objects in that particular class. So that's what basically it does. So let's just create a class for defining a species of an animal. Let's say a dog, for example. So how we're going to do that? Type class, and the class name is dog, and let's type species as let's type species as an as a variable, and let's say canine. Canine means dog. All right. So this is a class variable. Why? Because it is stored inside this class. There is no functions defined yet. Now let's create an init function. All right. How are we going to do that? Def underscore init self. With that, we're going to create some two parameters here. So name and age of the dog. So this is what you call as initialize instance. So we are initializing the instance here. Now what we're going to do is we're going to type self, because we're calling the function itself, and then self dot name is equal to name. We have typed two dots. Name is equal to name. Alright. So the parameter is passed here and it is empty. But how we are passing it without even having the data? That is what init does. We don't have a data, but it initializes the variable. Okay. Let's move on to age. It's same as the name. So self dot age is equal to age. Alright. Now let's create another function here. So since this is an init function, this is what is going to execute in the first place when you call this class. Whenever this class is used, this will be initialized first. Alright. Let's move on and create a function called as bark. Okay, so this is for the secondary function. So def bark print, let's create format and self dot name. So we are passing self dot name, but the thing is still we don't have a value for this variable, but we are passing it because it is initialized using the init instance. Alright. Now let's say it says woof. Alright. Now let's create an object for this to use this class. Okay, so dog1 is equal to dog, and then we're just straight away writing the data because it is initialized and we don't want a function to be called in the name of init. Okay, so the dog name is Buddy and his age is 3. Let's move on and create another dog. So dog2 is equal to dog, and I would like to call dog2 as Max, and his age is 5. Alright. So we have created two objects in the name of dog1 and dog2. Let us print all the computed values. So print dog1 dot name comma dog1 dot age. Just like that. We can go ahead and type print dog2 dot name and dog2 dot age. Alright. So if we run this script, we can see the dog's name and age is created and it has been passed to the init function here. But since we have a class variable, how we're going to use that? And a class variable is widely used across all types of functions inside the class because it's used outside a particular function, so it can be accessed anywhere. So for that, instead of this age, I would like to replace that with species. Alright. So since we don't have any condition for defining the species, the default species will be canine, and that will be printed next to our names of the dog. There we go. Max canine, Buddy canine. So this is the difference between class variable and initializing instance. Alright. Let's move on to inheritance. What's inheritance anyway? So inheritance is nothing but simply you can borrow a particular feature from a class to another class. Like, let's say if a class 1 has a feature and you want to use that particular feature in class 2, you don't have to define the entire feature once again in a function inside that secondary class. Instead, you can use inheritance and use the first class's feature inside the second class. That's what inheritance does. So let's move on and create a class called as car. So I want to use the same class which I used in the first place. So class car, def drive self, okay, it's already created, self print room, okay. And now what I'm going to do is, let's create a secondary class. So class electric car, alright, and I want to call this class variable inside this class, so we can type car. Alright, so now we are inheriting the class car to our electric car. Alright, now let's move on and create a function. So def charge, so we need to charge the electric cars, right? So charge, what we're charging, print batteries are charging. Alright, now let's create an object for this. So I would like to create an object called as Tesla for an example. Tesla is equal to electric car, we all know that, right? Now first let's drive the car, but as you can see, Tesla is an electric car, but the drive function is stored inside the car. How are we going to use that? Well, we can use that because the function is defined and the car class is inherited inside electric car. We can even drive electric cars, right? Not only fueled cars, we can even drive electric cars. So we can use Tesla dot drive, just like that. It's a magic, right? Now Tesla dot charge, we can even use the secondary class as a function, just like that, simultaneously. Let's go ahead and print that. We can see vroom from the first class and batteries are charging from the second class. So this is what you call as inheritance in Python. Let's move on to encapsulation. So what's encapsulation anyway? Just like its name, we are capsulating data. We're hiding the data to keep it safe. You know, well, it uses the private attributes with 2 underscores and it provides across methods. So it's like locking your house and giving the keys to your trustworthy neighbor, just like that. You are giving the keys, but you know that it is being used properly and they won't intrude inside your house, right? So that's what you call as encapsulation. Basically, you are hiding a stuff. When it comes to security or hiding stuff, the first thing that comes to our mind is bank account. Yes, so we are creating a class called as bank account, and let's create an initializing class. So def underscore init, and let's create self. I want owner and balance in their account. Go ahead and create objects for this initializing class. So self dot owner is equal to owner. Alright, just like that. But the balance, we need to hide that. How are we going to hide that? It's very simple. So type self dot underscore balance is equal to balance, just like that. Very simple. So this is a private attribute. Alright, now let's create another class. So def deposit, and we're going to deposit amount. Alright, so now let's move on and create an if statement. So if amount is greater than 0, in that case self dot underscore balance is amount, so it will be added to the balance variable, but it is hidden. So print format deposited curly brackets amount. Alright, just like that. Now let's move on and create another function for this. So def get balance. Okay, self. Now we are going to access that encapsulated data. We're going to type a return statement for this. So return self dot balance. So we get the balance of that user by returning that value. Alright, let's move on and create a new object for this class. So I want to create a variable called as account, and it will be initialized from the bank account, and the user details are Alice, and the balance available, let's say 1000. Alright, now I want to deposit an amount, so I'm gonna deposit, let's say I want to deposit $50, 50 rupees or something. Now let's just print account dot get balance. So we're getting the balance from the encapsulated data. So let's go ahead and run the file. There we go, the amount is deposited and we get the final amount as 1050 currency. But in this output we can see that nowhere the private attribute has been leaked unless until we are using it properly. Alright, so this is what you call as encapsulation in Python. Moving on to polymorphism. Polymorphism lets different classes use the same method name but behave differently. It's like how both dogs and cats speak, but one barks and the other one meows. So let's start by creating a class for polymorphism. Just as I explained, let's create a class called as cat, and then we're going to create a function called as speak. Alright, and it adds self, it's already loaded. So how cat speaks, it meows, right? Now let's go ahead and create a class called as dog. Def speak, and how dog speaks, barks. Alright, now let's create an object. Pets is equal to, so we have both cat and dog. Alright, let's create a for pet in pets. We are going through pets, pet dot speak. As you can see in the object, we have a variable pets. We are passing both of these classes, and then we are creating a for loop. For that we are creating pet as a variable, and what we are iterating is we are iterating through this variable which includes both of these things, but both of the functions are in the same name, but it will be behaving differently because dog barks and cat meows. Let's try it out. There we go. So first cat meows, and dog barks, just like that. Alright, so this is what you call as polymorphism. And with that in mind, we have came to the end of this module, and for the project I want you guys to create a bank management system with customer accounts, deposits, withdrawal and statement methods. After completing the project, you can upload it to your GitHub repository and share the link from the link in description box down below, or anywhere in what platform that you are seeing this course. Alright, with that in mind, let's move on to the next module. Hello everyone, in this module we're going to see about request library. So what's requests anyway? So request is a library in Python which is used for triggering HTTP requests in Python. Basically it is used for fetching API keys or downloading files from the web. It's more like a browser inside your code. Okay, so that is what you call as requests. Now we're going to see about request library and some of its key functions and features available. So we'll go them one by one, and without any further ado, let's get started. So first we have to import requests. Alright, so to import that, just type import requests. That's it. So it's a pre-installed library in Python, so you don't have to install it from pip. Alright, Now the first thing which we are going to get is we're going to make get requests. So what is get requests anyway? So which is nothing but we're going to go for a URL and try to fetch its status in our code. Alright, so let's do that. So how we're going to do is just go ahead and type variable. So I'm going to type variable response is equal to request.get. Alright, now in this I want you guys to type an URL. So for this I'm going to type https://api.github.com. there we go. Now I want you guys to print response dot status code. There we go. So if I just go ahead and hit enter or just run the file, you can see we get 200. So 200 means it is successfully fetched, which means this particular gateway is accessible for our code, and in that case we get a successful 200 code. Alright, so this is how you do it. If you get something like 404 or 504, something like that, in that case you might have error. Each of those code have different reasons to display. Now let us go ahead and fetch a particular document from this API URL. So what I'm going to do is I'm going to type another print statement, and I want to fetch a JSON file, and not the entire file. I want to get a particular column from that file, a particular key from that file. How are we going to do that? Go ahead and type response.json, and then I want to type a square bracket, and then with quotation type current user URL. Alright, so this will display a piece of JSON file. So let's go ahead and run this. There we go. So this is our user URL, which is api.github.com/user. Alright, so this is how you fetch from a web server, or when you fetch from a API gateway, everything can be fetched from right here. Alright, so now let's move on to handling response content. So we're going to handle a response content from this, which means if you're fetching a data, there will be a tons of different types of data. It's like a delivery box, for an example. It has lot of other things, and let's say you order a cell phone. In that case you have a cell phone and its user manual. In some cases you will have your tempered glass and all the other stuff, right? So we want to fetch only a particular piece of data. In that case, what we're going to do, that's what we're going to see now. So what I'm going to do is, let's go ahead and another variable, response is equal to request.get, and what we'd like to get is https://json placeholder.typicode.com/posts/1. Alright, now I want to get the raw text of the response. For that you can type print response.text. Alright, so if I run that, there we go, we get a raw response text. And then let us go ahead and fetch the JSON from that URL. So how are we going to do that? It's very simple. Just type response.json. Alright, so if I run that, we get the JSON, which is this one, right? There we go. Now let's say I want to get the headers, like the type of the file or something like that. That's what you call as header. So I want to get the content type of this response. So response.header, and now go for a square bracket, and with the quotation type content type. Alright, so if I run this file, there we go, application/json, and the character set UTF-8. So this is the content type, so that's what we get. We fetch it from here and we get the output. So this is how you handle the response content. Alright, let's move on to passing parameters in GET requests. So just like in functions, we can pass parameters in the GET statements right here. So how we're going to do that? Let me show you. So what we're going to do is we're going to go ahead and create a parameters, but I want to store that in a variable called as params, and inside a curly bracket just type user ID for an example, not OD, it's ID, yeah, and then type a colon 1 and a comma. I would like to add the ID colon and 2. Alright, so now go ahead and type another variable here and go ahead and type requests dot get, and what we're getting, it's from the same URL. So https / JSON placeholder dot typecode.com/posts comma params is equal to params, which is the variable that we have over there. Now let's go ahead and type we're gonna print the response URL. Alright, and we're gonna print the JSON file. Okay, so response.json. So let's run the file. There we go. So now we have fetched the user ID and ID, and we get all the other data which is fetched from that particular placeholder. Alright, it's just like that. And then we can make post requests. So with GET requests, we fetch the data from the server or any type of gateway, right? But in post request, we send the data to a server. So we're going to send a particular data to the server, and it will show the output as 201 when it is created. Alright, else it will show any type of error code according to the type of error which is occurred. So let's go ahead and create a new variable which is data. So this is the data that we're going to send to a server. So I want to send a title, and what's the title anyway? The title is my post. Alright, and then I want to create a body for that post. So let's say hello world for an example, and the user ID. So my current user ID is 1, right? Now let's move on and create the response variable. Requests dot post. What we're gonna post is in the URL. So https dot / JSON placeholder dot typecode.com/posts, and then with a comma I'm going to type JSON is equal to data. Alright, so we're going to post this into a JSON file, and we're going to post that to the server. So let's go ahead and print the status code, which means we'll understand whether it is success or not. So response.status code, and then print, I want to print the JSON file which we just posted. So JSON, there we go. So let's go ahead and run the file. There we go. So we get 201, which is the success code, and we get the data which we just posted. Alright, so just like that we got that. Right, now let us go ahead to error handling. Just like in the previous modules, we have error handling in this requests library too, because when we get 201, which is a success code, and 200 for a success code, we might get any other code which resembles error, and we have to handle that error, right? So that's why we're going to see how to handle the error in request library. So let's go ahead and create a try. response is equal to requests dot get. So here I want to type an URL which doesn't exist. Okay, https / non-existent dot API. Good. Now I'm going to type a timeout variable, which is nothing but it will try for 5 seconds, and then it will give us a code, an error code. So let's go ahead and type an except block. So except requests dot exceptions, and what type of exception we get? Connection error, right? So connection error, because this URL is not existed. So we're gonna get a connection error because we failed to connect, right? So print what we're gonna get: failed to connect. That's it. Now let's add another except block. Okay, so except requests dot exceptions, and we also have a timeout variable, right? So we'll try for 5 seconds and we will get the timeout error. So let's type timeout, print request timed out. There we go. Now let's type one more except block, which is request exception. Alright, which means the entire request is messed up. In that case, we cannot access the particular URL or the API gateway. We'll get this error. So requests dot exceptions. What exception? We're gonna get request exception, right? So request exception as E. I want to print E. That's it. So let's go ahead and run this file. We get failed to connect because this is a connection error, right? And if it gets connected, if we replace this with another URL, in that case we will get timeout error if it doesn't work. Else it will show you this request exception error, which means the way that we approach the URL is itself wrong in that case. Let's move on to working with headers. The headers let you customize the request, like setting the authentication or content types. It's more like an ID card which you show to the server to let you in. Alright, so that's what you call as headers. So let's see how to work with headers. So for that, I would like to create a new variable called as headers. Headers is equal to, with a curly bracket, let's type user agent. Alright, and then I'm going to type my Python app for an example. Let's go ahead and type accept, and what we're going to get is application /JSON, which is nothing but we only accept if the content type is application /JSON file. Alright, now let's move on and create the response variable. So response is equal to requests. Here we are fetching the data, right? So that's why we're going to use get. So request.get, what we are getting from https //api .github.com and what we are fetching is the headers. So headers is equal to, we will pass the headers JSON over here. There we go. Now let's go ahead and print the headers. So response.headers, and then we'll print the status code, whether it's successful or not. So response.json. Alright, so let's run the file and we get, there we go. So we are printing the headers, so with the date and all the other stuff. The content type is application /JSON, and we get all the other details as well. So we are accept encoding, accept. Okay, so we get all the data from api.github.com, and as well we get the JSON file from the response variable. Alright, then let's move on to handling authentication. So here we are just accessing the server, right? but we can't access any type of server from any user type, because we get authenticated before accessing a server, because an authenticated server is one of the best ways to prevent intruders from accessing your server, right? So how we're going to do that? It's very simple. So let's go ahead how to get credentials and access a particular type. Let's see how to add credentials and access a particular server. This is more useful for if you are using any type of credential based API, or some APIs are paid. In that case, you need your credentials in case to access that particular API file. So how we're going to do that? Let's go ahead and type the response variable. So response is equal to request.get. What we're going to get is https //http bin.org. I'm going to type quotation. Okay, there we go. org/basic-auth/user/passwd. Alright, now we're gonna add the authentication for that. So auth, what type of auth is? It is user and passwd. Alright, there we go. And then let's go ahead and print the response status code. So print response dot status code, and then with that let's just run this file. There we go, we get 200 because this is successful, because we are accessing the auth we are accessing this particular server with this user and password, with this username and password. So that's why this is a dummy credential. Well, this is for accessing a particular server. Let's say you want to access an API key. Alright, in that case we will use some kind of token based credential. So let's see how to access that. Okay, so let's go ahead and create an header. So headers is equal to, and I would like to create authorization colon bearer fake token. So we are getting a fake dummy token, and then let's create the response variable. So response is equal to request.get. What we're getting? https /api.github.com/user. Alright, now with the header the headers pointing towards headers. Alright, now let's go ahead and print the status code. So response dot status code, and if we print that, we get 401. This is because we cannot access the we cannot access the API with a dummy token, right? So that's why we get the error code 401. We are unauthorized. Alright, access the server with authorization. So now let's move on to how to see. So let's see how to download files. Now let's move on to the next topic. So the next topic is how to download files using requests. If you're creating a huge level of, so let's see how to download files using requests. So let's say you're developing a huge application or a huge software. In that case, you need to download some required prerequisites for your project to make your code run more efficiently. So how are we going to download that? It's very simple. So for downloading files, first we need to create a response variable which defines the user, which defines the URL. So response is equal to request.get. What we're getting? https example.com, which is a dummy URL. So example.com/image.jpg. Okay, alright, so yeah, image.jpg. Now let's go ahead and type stream is equal to true. Alright, because we're avoiding big files, so that's why we are using stream is equal to true. Now if response dot status code is equal to 200, if we succeed, then with open, what we're opening is downloaded image dot jpg, alright, with WB format. So what's WB anyway? So WB stands for write binary, alright. So WB has file. Now for chunk in response dot iter content chunk size 819.192. Alright. So what's happening here? So we are downloading it as a binary, and we are downloading chunk by chunk, like every minute set of data one by one, and we get the chunk size of 8192, and then we are downloading the entire file in chunks, and we are collabing it to make it as a single file. So file dot write, what we are writing is chunk, so we are writing this data to this image file right here, alright. And then so print image downloaded, and we'll create an else statement, print download failed, alright. So let's just go ahead and run this file. Download failed. This is because this particular image right here, this URL is invalid, so that's why we get this error, alright. So let's go ahead and see whether we can download a file. So I'm choosing this site, so let's choose this this image to be downloaded. So right click that, open that, so let's open the image in new tab, and there we go. From the URL here, there we go. So let's go ahead and run the file. Image downloaded, alright. So if we go here, we get downloaded image. When you open that, the image is downloaded, right? So this is how you do it. So this is how it works. So we have downloaded the file chunk by chunk, and that is displayed over here. So let's move on to session objects, and this is for persistent settings, alright. So sessions is like creating a logged in space for your code, like it saves the settings or the type of settings which you have defined in the previous fetching or posting. So it's like creating a particular session tab in your browser, like for each user, and all those data will be saved inside your code, and you can reuse them whenever you want, alright. So let's see how to do that. So let us start with creating a session. So session is equal to requests dot session, alright. So what we're creating is session dot header dot update. We are updating the headers. So user agent is my Python app, alright. So response 1 is equal to session dot get. We are getting from two URLs, so https / http bin / headers, and then we get response 2 is equal to session dot get. What we're getting is https / http bin.org/cookies. Okay, I want to replace this with org. Yeah, there we go. Now let's go ahead and print the JSON for that. So response 1.json, and with square brackets let's type headers, and then another square bracket let's type user agent. That's it. So let's run this file, my Python app. Alright, which is nothing but we are updating the header of the previous http bin post request, and we're getting that from the URL, and we are printing it. Alright, so that's what is happening here. With that, we have came to the end of this module, and for this module I would like you guys to develop a URL checker. So I want you guys to create a code which fetches an URL, and whether the URL exists or not, a valid URL or not, and then give the output. And with that code loaded in your GitHub repository, I would like you guys to send me the code from your GitHub repo to the link in description box down below. With that in mind, let's move on to the next session. In this module, I would like to cover 3 of the mainly and most commonly used Python libraries, and that is math, random, and datetime. Okay, so let's go through them one by one. And now first let's start with math. So according to this name, you can understand that it is related to mathematics. Okay, so it's nothing but we can do mathematical calculations and problems in Python. Well, you may ask me, well, we can do that without this library, right? For basic addition, subtraction, and all those stuff. What about let's say, what about mathematical identities such as sine, cos, and all those things? Let's say logarithms, exponentials, all those things. You'll be needing this library called as math. So let's just go ahead and start by importing the library math. So import math. Now using this library is very simple. For example, let us say I want to print the value for pi, so we can type math.py. In that case, you'll get the value for pi. There we go, 3.14. Let's say I want to print the value for exponential, which means e. In that case, we get 2.71 as the default value. So it has a lot of predefined identities and functions which prints the values just like this. Alright, when you just hold Control and click on math, you'll get into this math.py. So this is the entire Python file of the library. As you can see, all these values are predefined, and with this we have the functions. These functions are widely used to do mathematical calculations, so that if you're using this library, you don't have to work on all these functions on yourself. You can just go ahead and import math and practice mathematical operations in this library itself. So let's go ahead and do some basic functions. Let's say you wanna get square root of a number. So x is equal to, let's say, 26, and you want to print the square root of 26. How to do that? It's very simple. Just go ahead and type math dot square root. We're gonna print the square root of x. Alright, let's just print, and there we go. 5.099 is the value. So this is the square root of 26. Let's say you want to get the power value of a number. Alright, in that case, how would you like to do it? Let's say I'll just remove all these things, and I'll directly print the value of math dot power. I'm gonna print 2, 3, which means 2 to the power of 3, which is 2 cube. Okay, so we're printing the value of 2 to the power of 3, and that is 8. Alright, not only that, we can even print factorial of that number.
For example, let's say x is equal to 250, and then if I'm printing the values, let's say math dot factorial, and I'm gonna print the factorial of 250, which is x. So I'm just printing that this is the factorial of 250. Alright, it's just like that. Now let's go with round offs. So round offs is nothing but, let's say you have a value, let's say it's a decimal value, and you would like to round off the value. There are multiple methods that you can do it. For example, let us say math dot seal, and now we get we should enter a value here. So seal means, let's say ceiling for an example. So ceiling means up, so we are rounding up the value, and then we get 5. So we are rounding up the value as 5, and while rounding down the value we type floor. So ceiling and floor. In that case we get 4 as the nearest value. Let's say you want to truncate the decimals. In that case you can just go ahead and type trunc. Now we are truncating the value, so if I'm just printing the output, we get 4. Alright, let us move on with trigonometric functions. So for trigonometric functions, we can, let's say I want to print the trigonometric functions is nothing but sine, cos and all those stuffs, right? So we can print math.sine, math.radians. I want the radians like 90 for an example. We are printing the values for that. In that case we get 1.0. So we are getting sine 90 degrees, and that is 1.0. Just like that we can print math dot cos, let's say 0. Cos 0 is equal to 1. Alright, so we can verify that by going here, then trigonometric table. When you go there, we can see here sine 90 degree is 1 and cos 0 is also 1. Alright, so that's why we get cos 0 as 1. Let's say I want to print, let's say what about sine 30 degree? In that case we get a different value. Alright, so just like that we can get all the trigonometric values like that. And also we can print the pi value, for example the trigonometric inverses, right? So for that we can just type print math dot tan, and we're gonna print math dot pi divided by 4. So pi by 4 is equal to tan pi by 4 is 0.9999. Alright, so this is the basic trigonometric functions that you can do with math library. Let's move on with logarithms and exponentials. So for printing logarithms in math library, we can go ahead and type math.log. So we are printing log with 100 with base of 10. Alright, so for that we get 2.0. Alright, let's say you want to print for log base 2. In that case we can go ahead and, let's say I want to type 8 here and log 2. In that case we get 3.0. There we go. Yeah, so now not only that, we can even type exponentials as I said before. Let's say I want to print exponential of 1. So e to the power of 1 is equal to 2.71. Alright, now we have some other useful functions in math as well. For example, we can print absolute values of a number. Let's say print fabs, and we are printing absolute values, so 5.5 for an example. So if we are running that, there we go, 5.5. Not only that, we can even print GCD, which is nothing but global common division. So for global common division we can type GCD. I'm gonna type 48 and 18. So these are the integers. The value is 6. Alright, not only that, we can even check whether a series of numbers is infinite or not. For that we can use is infinite and 1, let's say 1e308, and is that infinite? It's false. Let's say is finite or not. Yes, now we get true because it is finite value. Now, so let's move on to the next library, which we're going to see is random. So import random, just like we do on math. Random is nothing but it just has a random set of data, and with that your computer will select some set of data and it will generate according to your conditions. For example, let's say you're creating a password generator. In that case, you can use random library and generate alphanumerical values as a random password. Let's say you want to print a random integer for now. So for that, we're gonna go ahead and type random dot randint. Now I want to print a value from 1 to 10. So it will just go ahead and take this 1 to 10 as the limit, and it will select one value from that particular set. So if we just run the file, we get 9, which is the random value generated from 1 to 10. Let's run it once again. We get 7, 10, 1, 10, 1, just like that. We get the values again and again. Alright, let's move on to random range. So it will just we have to allocate a range, and with that range it will print a random value. So let's type rand range, and then we're going to go ahead and type 0 to 10. Alright, now it will start from 0 to 10. Now I want to print random values which is even, so for that I'm typing 2. So it will skip 2 steps and print the values. For example, if you take 0 to 1, it will print 0, it will skip 2 and it will print the third value, like that. So we get 0, 8, 6, 0, 4, 0. So we get values which is even and it is under 0 to 10. Okay, so now let's move on to random dot random. It's the random function, random dot random. So it's a default function in random. So if I just type random dot random, that will give us a floating value, which is a decimal value. Alright, and then we have a uniform function in random, that is it will print random float, and with that float we can set the limits, which is just like random dot random. So let's go ahead and type random dot uniform, and I want to print from 1.5 to 2.5. okay, so 2.5. if I run the file, we get 1.72, which is between 1.5 to 2.5. alright, so this is random dot uniform. Let's say you want to access sequential operations in random. Let's say you have a set here, so I'm gonna have a list defined here. So data is equal to apple, banana, orange. Now this is 3 fruits stored in the data. It's a list. Now if you want to print a random fruit from that, we can type random dot choice. In what we're gonna select, it's from the data. So let's go ahead and run it. We get orange. Let's run it once again. We get banana. Let's run it once again. We get orange again. Apple, banana, orange. So we get random values from the sequential set. Alright, not only that, we can even have random choices. So this is a single choice, so we get multiple choices from this. So to define that, we can type random dot choices, and we're gonna use data as the set. By adding a comma, we can add weights for this data. So I'm gonna add weight. Now it will pick 2 items. Okay, so it will pick 2 items from the set. So for that, let's type 10, 30 and 60. In that case, we'll go ahead and type k is equal to 2, and that will print 2 of the random items from the data. So let's try it. Orange, 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 banana, banana,
orange orange, banana orange, orange orange, orange banana, orange orange, orange orange. As you can see, it is printing two of the most weighted fruits, and that too it has two choices. It's random, right? So that is why we use random dot choices. So this is valued from the weights. Let's say you don't want to just add the weights, you just want to print a random two values. In that case, what we'll do is we'll just type sample. Okay, we're taking the sample from the data. The number of values we're going to take is 2. So we get different values but without the weights. Not only that, we can even have shuffle values. Alright, so what is shuffle values anyway? Let me show you. We can go ahead and type, let's say random dot shuffle. We are shuffling data. So now all these values will be shuffled. So let's print that. Nothing is happening because we need to print them, right? We need to print the values. So now after shuffling, I want to print the data. So let's run this. Orange, apple, banana. As you can see, the values are shuffled. Let's print them again and again. We get the values shuffled. Alright, now we can even get Gaussian distribution in random. How are we gonna do that? It's very simple. Just print random dot guess, or sorry, Gauss. Okay, in that I want to add, let's say, 0 and 1. So it will print Gaussian distribution with mean 0 and standard value as 1. In that case, we get a decimal value. Alright, and we can even add a uniform here, and we get A and B as the parameter. We get 0.99 as the value. We can even add expovariated values, which is nothing but it's exponential distribution with rate 2. Alright, so I'm gonna set the rate as 2, so expovariate 2, and now we get 0.47, just like that. Now this is basically random. Now let's move on to date and time. So date and time can also be imported with import date and time. Now what I'm going to do is I'm going to print the current date and time now. So for that, I'll create now is equal to datetime dot now. Alright, now let's print now. If I run the file, we get the current date and the timestamp for this day. Alright, now we can even get today's date. So for that, we get today's date. We can see that we have the timestamps printed. Let's say we want to get the date alone. For that, we can just type date. Alright, so if I just type the date and run the file, we get the current date alone. Alright, we can even type and get specific dates and time. For that, go ahead and type let's say specific is equal to date time dot date, and I want to get the date of Christmas of 2025, so 12/25, and if I run the file, we get the current specific date is right here. So now if I print the specific value, we get the values printed as the date format. So specific, now we get, there we go. So this is how you define a date. Let's say you want to define a time. How you will do it? So it's very simple. Datetime dot time, and we can go ahead and let's say 2:30 in the afternoon. Okay, if I print that, we get the time. Alright, let's say you want to print date and time together. In that case, we can type date time, and then let's add the year first, the month, and the day, and then the time. Now let's run this, and we get the date and time together. Alright, we can go ahead and get the output of the time delta, which is nothing but the time duration. Okay, so for that, we'll go ahead and create a variable called as delta and type date time dot time date, sorry, time date time dot time delta, and days is equal to 7, and hours is equal to 12. Now we get, oh, we have to print that, right? So print delta. Now we get 7 days and 12 hours as the output. Now let us say I want to add the duration from now to this parameter. How you will do it? Let's create another variable from the previous sections. So that is now is equal to datetime dot date time dot now. Alright, now I have to go ahead and add another variable here, that is future is equal to now plus delta. Now I want to print future. Now if I run the file, we get the value, which is 7 days after today and 12 hours after the time. Okay, now we can even format the code. Like for example, if you're printing the date, for an example, we get year, month and day as the default format. Let's say you want to modify that format here. So for that, what I'll do is I'll just remove the future and the delta, and in the print statement I would like to add one more thing here. So that is formatted is equal to now dot strf time, and that is I have to add another quotation here. Now percentage y hyphen percentage m hyphen percentage d, and then the hour. So percentage h colon percentage minute hyphen colon percentage second. Now if I run the file, we'll get the today's date and time in this format. So if I run that, nothing. Okay, I gotta print that. Okay, so print formatted. Now if I run that, we get it in the correct format which we want, which means the extra seconds are disappeared here. Alright, so not only that, we can even go ahead and parse the particular time. For example, let's say parsed is equal to date time dot strp time, and then I'll just go ahead and type 2025 12 25 and afternoon 4:30. Okay, 14:30, and then with this format. So let's say y comma okay, so now we're printing this date string into this format. So now let's run that. I gotta print that, man, parsed. Okay, so now we get the correct value. Alright, and then with the date and time library, we can even have a particular time zone printed. For example, let's go ahead and type UTC is equal to date UTC is equal to date time dot date time of now, and then I want to print date time dot time zone of UTC. Okay, now we get the correct time zone of UTC, but I gotta print that UTC. Now we get the actual time zone of UTC in this moment that I'm recording the video. Let's say you want to print the offset, like for example IST for an example. So we are printing the current offset of the time. So offset is equal to date time dot time zone of date time dot time delta, and with hours is equal to 5 and minutes is equal to 30. Alright, let's run the file, but before that let's just type ist is equal to datetime dot now with the current offset. Alright, which is let's print that. So let's print utc. So let's print ist. So let's run the file and we get the time. So this is the end of this module, and for this module I would like to give you the activity to develop a random math quiz generator. Okay, you'll use random library, math library, and date and time library with the timestamps and all those stuffs to be added, and you can share the code which you've done in your GitHub repository with the link attached to the link down below, and you can fill the form and fill the link over there.
That's it for today, guys. So I hope that you have learned some of the basic concepts in Python, and if you find this course helpful, you can share this with your friends and like this video, and also subscribe to Tech Fortitude for more informative videos like this. And of course you can submit your GitHub repository of all the activities that I've said in this video in the link in description box down below, and I'll see you guys in my next video. Until then, bye. And also comment down below what's the next video that you need, and I'll make it and upload it very soon. Thank you.